Hello, everyone, and welcome to this new webinar from OpenAIRE. We are going to start in a few minutes, waiting for the people to come in. So in 1 minute, we will start. Thank you. Okay, thank you everyone for coming today, and welcome to this OpenAIRE webinar. We are going to present you the OpenAIRE graph for science, technology, and innovation policy, and in particular the case studies from the IntelComp project that is about to end this month. So a few housekeeping rules. This session will be recorded and will be publicly available. If you have any questions or comments, you can post in the chat. Please make sure that you add your name and your affiliation, and when you are speaking for the questions, please introduce yourself. And you can upvote any questions you would like, so our speakers will prioritize the questions that you are making in the question and answer chat. So today we are going to introduce the OpenAIRE graph, thanks to Thanasis Vergoulis. Ioana Gripari will present the evidence-based policies of the OpenAIRE graph and what we did in the IntelComp case studies. We will give you the floor for posing questions and for our speaker to answer. And we will do the final remarks before we say Merry Christmas to you. So today we have Ioana Gripari, who is a senior researcher from the Athena Research Center, and Thanasis Vergoulis, who is the development and operation director of OpenAIRE. So thank you. I will give the floor to Thanasis to start the presentation. Thank you.
Thanks, Julia. So let me share my screen. Okay. Thank you everybody for the interest. I will attempt to offer you a very quick introduction to the OpenAIRE graph. The OpenAIRE graph is one of the largest and most inclusive bibliographical databases or scholarly communication databases. It is capturing bibliographical metadata for publications, research organizations, datasets, research software, researchers from all over the globe. It started giving focus on the open material, but it also contains restricted material as well. So here on this slide, you can get a glimpse on the underlying data model of this graph. You can see that one of the main entities is the research results, which can be a publication, a dataset, a research software, or something else, like, for example, a poster, a DMP, a project deliverable. For each of these research results, we have the connections to particular data sources that are providing this metadata. These are the original data sources providing the metadata. For example, the original repositories or the journals. We have connections of them to communities. We have connections to projects, funded projects, particular grants, and of course we have connections to organizations and a lot of other information as well that can be useful in various scenarios. For example, we contain the venues, the graph contains also the venues that the results are published. They involved researchers and persistent identifiers like ORCIDs. Additional information like the fields of science and the SDG classifications for a lot of them that can provide some insights about the respective topics, but also some indicators about the usage, the downloads, for example, in the views in several platforms, and the impact based on citations, for example, of all of these results. And you can see from the numbers that currently, the graph contains metadata for more than 170 million publications, more than 59 million research datasets, more than 3,000 research software packages, and a lot of other research products as well. But how is this resource created? OpenAIRE is harvesting a large variety of data resources like repositories, publishers, open access journals, registries, aggregators, CRI systems, which follow the OpenAIRE interoperability guidelines. These are considered to be onboarded data sources that their contents are incorporated through a service that is called OpenAIRE Provide inside the graph. And notable examples of these onboarded data sources are Zenodo and Episciences, for example. On the other hand, apart from these onboarded data sources, OpenAIRE also incorporates metadata from some major instrumental data sources like ORCID, like Microsoft Academic, like Crossref, like PubMed, DataCite. And all these metadata are then homogenized, aggregated, cleaned, deduplicated, enriched using different sources for enrichment. For example, we have a large workflow that analyzes more than millions of full text PDFs and XMLs of open access papers to identify useful entities, mentions of useful entities like affiliations, like acknowledgements of funding, like countries inside these publications. And this enriched graph is then finalized and made available through the public graph dataset, which is released once in each 6 months, and through the API that it is updated more frequently in a monthly basis in most cases. And the graph is then being used also to develop added value services for researchers and other stakeholders in the research community at large. Of course, there are the OpenAIRE added value services like OpenAIRE Explore, OpenAIRE Connect, OpenAIRE Monitor, the Open Science Observatory that are consuming data from the graph. to provide useful services for the research community. But there are also a lot of third-party services from the European Union, from publishers like Elsevier, that are also consuming data for the graph to provide functionalities to their end users. And in some cases, the added value services of OpenAIRE have some features that the end users can provide some feedback to the graph and maybe suggest some fixes in the contents or some additions. So the services themselves can also improve the quality of the graph contents. And before going further, I would like to just mention two highlights of the contents of the graphs that are two developments of the last few years. So the OpenAIRE graph, as I mentioned, contains classifications for the fields of the various publications. More specifically, there is a classification scheme from a team of Athena Research Center, and this classification scheme is called Synobo. And based on that, which offers a hierarchy of classes that are describing different topics, different scientific topics. We have classifications for more than 40 million publications right now in the graph. And until the end of this year, we expect to have the same information for more than 100 million publications. A second highlight is that the graph also contains information about the usage and the impact of the various publications and datasets and other research products. Of course, we have citations coming from open citations, but also from other sources, like the Crossref itself, PubMed datasite, and also a set of indicators that can be calculated using network algorithms on the citation network, or a set of usage indicators based on the downloads and views of each of the papers, for example, in the respective repositories, are information included in the graph, which is also made available through the various front ends that the OpenAIRE services are providing. For example, this screenshot here has been taken from Explorer, from OpenAIRE Explorer. So more or less, these are the basics for the graph. I'm not going to say a lot more. You can find a lot of details inside the OpenAIRE graph webpage, graph.openaire.eu, and in the respective documentation website, which is the graph.openaire.eu/docs. You can find a lot of details about how we are producing the respective data. And in general, you will very soon understand that this is a very rich resource that aims to act like a full map of science containing information not only about publications, which is the main focus of other resources, but also about everything around research, like datasets, like software, and even more. And if you are interested, this is the perfect timing for you, because from January, we have a new series of community calls that will be focused on the OpenAIRE graph. The first community call for the OpenAIRE graph will happen on January 17th. at 11 a.m. Central European Time. And Paolo Manchi, who is the CTO of OpenAIRE, will provide a more detailed introduction to the OpenAIRE graph than the one that I made today. But also he will discuss about the scope of this series of talks and series of events and what to expect. And also, as all the community calls, we are going to give the mic to the audience to provide some feedback, to ask for clarifications, and we're going to provide the answers to all this. So if you are interested to that, into that, you can follow the link that appears in that slide to register. But if you follow also the social media of OpenAIRE, you will stay tuned for sure, because new announcements will happen soon. Before closing, let me say that these community calls are going to provide very useful information for the graph. In some of these calls, we are going to discuss about the most recent developments, the most recent additions, the technological changes and advances in the workflow, the production of the graph, new data that are included and things like that. In others, we are going to provide a hands-on experience on the data of the graph, giving examples with some notebooks that can be used together with the beginner's kit that we have in the graph, so that people can see in practice how you can use the data of the graph to perform various types of analysis. And of course, in others, we are going to go into more details about particular functionalities that are mature and are provided from the graph development team. And with that being said, thank you all for your interest. If you want to contact me for more details, you can find my email and my social media here. Thank you again.
Thank you, Thanasis. Before giving the floor to Joanna Gripari, we have a question here in the chat for you, and it's about the use of Microsoft Academic. Because the question is, since it was shut down, here Amanda French from ROR would like to know if we are harvesting data from OpenAlex as well.
Thank you for the question. No, currently we are not using any data from OpenAlex because the data that we are getting from Microsoft Academic Graph, we are now getting the majority of them from other sources. A lot of information is also extracted by our technical team from the full texts that we are collecting. And of course, as you know, the coverage of some of the sources like the Crossref is always increasing. OpenAIRE also has thousands of repositories and open access aggregators and CRIS systems onboarded. So at least for now, we don't have any plan to incorporate a major part of OpenAlex. One of the things that, for example, we missed a lot when the Microsoft Academic services were discontinued was the fact that Microsoft Academic provided a large coverage in affiliation links, connections between the research products and the organizations. But we are apart from the fact that we have in place various workflows to take advantage of the connections of, for example, the repositories to particular organizations, or because we are consuming data from Crossref that provide affiliations, or from PubMed. We are also developing our own solutions to improve in that aspect. And don't forget that OpenAIRE is a community-based effort. Research community is at the central point for OpenAIRE, and we have a large set of end users that we plan to take advantage of them, to leverage this power, let's say, to provide feedback and claims about any missing information that we have right now.
Thank you, Thanasis. If I don't see any other questions, but we will have a question and answer session later. So I will give the floor to Jonna Gripari for showing us the case studies of IntelComp.
Thanks, and thanks everyone for being here. Let me share my screen. So hopefully you can see everything now.
Yes.
Yes. Okay. So IntelComp is a project that brought a bunch of us, 13 partners, together in order to satisfy this need that we saw in the landscape of research and innovation policymaking, or I'm going to be using STI and RNA interchangeably, sorry for that. So research and innovation has a pivotal role in digital transformation, boosting economic growth, in achieving the goals we have in the society. It is a priority for various actors. Not enough if you ask me, but it's a priority. And it's been changing a lot. So we see technology entering more and more in our day-to-day life, but also it's becoming quite fast and quite complex. And in terms of the cutting edge development, let's say. So we need the policy making in SCI or research and innovation to be up to date. So we need up-to-date approaches for monitoring, so ensuring compliance or tracking a particular policy that is implemented, evaluation, so that we can grasp the ripple effects across the entire society, and for agenda setting, so thinking towards the future and how policies should be set. So what we all agreed on is that combining traditional assessment methods with emerging tools and diverse data sources offers a deeper understanding of research and innovation landscapes, and we should do something about it. And obviously there's other people working on this as well. So the project started in January 2021 during the pandemic and before ChatGPT. And it's ending this month. So the idea is to build a platform to help policymakers and administrators design policy by incorporating a large amount of dynamic, multilingual, heterogeneous data, understanding it, and turning it into actionable insights for evidence-based policymaking. So the platform that we built is composed of several components. So I'm not going to give any of the technical stuff, but you can ask if you want. I will try to answer. So we're starting here on the top left with the policy framework. So we break down the policy cycle into different policy stages, from agenda setting to evaluation. And we interact this with the different sectors of a society where innovation can be seen or can have an effect on, from science, obviously, to industry, to people, to different sectors anyways. And then we anchor the framework and build the analysis for three particular use cases: climate change, AI, and cancer. Behind all that, to support the analysis, is the data space and catalog, data catalog that I will talk about the data space a bit later on, and the role of the OpenAIRE graph, of course. Then we have the processing tools, so various AI and NLP tools and other types of data processing tools. All of that is hosted in an HPC environment at the Barcelona Supercomputing Center, where it is optimized for, to be able to handle this amount of data and translation that's taking place. And in the end, we have the end user tools, which I will discuss in a second, which are the STI viewer, the policy participation portal, and the evaluation workbench. All of these components, what they end up doing is allowing us to go from a policy question to providing the analysis necessary to answer that policy question. And of course, we would like to build this type of environment in a way that is sustainable and reproducible and trustworthy. And we will see what role the OpenAIRE graph plays into this. So the end user tools that we built are the following. There's the STI viewer that is meant for decision makers, policy makers, and analysts. So it's a dynamic visualization tool that presents all of the analysis and the KPIs that we have constructed. So it's a way to take all this crazy amount of work and data and make it presentable, to BI dashboard, basically. And this is linked to the Policy Participation Portal. The Policy Participation Portal basically includes a survey tool which takes dynamically data from the STI viewer and asks academic, industrial, and citizen groups different types of questions based on the analysis, the answers to which it shows back on the STI viewer. So these tools are linked so that there is inclusive policy making, and there's an easy way to actually provide the analysis to these different types of groups. And this could be open to a more general audience, although they may have a hard time understanding the STI policy aspects of it, because the data is presented in a language for the analysts. However, the only reason why we opened it to groups and not to everyone, the entire public, is because at this point we haven't built something for curation of answers and so on, right? So we have to kind of limit it. So this is the duo of tools for evidence-based policymaking. And then we have the evaluation workbench that is meant for funding agencies, and it helps them with the ex-ante evaluation of proposals for funding. So it groups them by topic. It finds a similar proposal from some time ago from other funders that have provided the data. So it's a proposal evaluation tool, let's say. So let's talk about the data. So of course, it's all about the information we extract from the data, but there must be data there as well. So in the core of everything, we have the STI data, the IntelComp STI data space. Now this is populated first with raw data. The raw data is pre-processed in order to do some initial cleaning, let's say, and be able to analyze it afterwards. Then it goes through our NLP pipeline, and it passes through different types of tools and algorithms. Then it's post-processed and cleaned. Then it is aggregated into KPI. So at this point, we have the data analytics, which is, for example, publications annotated with different types of information that we have extracted, or company websites annotated with their innovativeness level, stuff like that. Then this is aggregated on the views that we are interested in. KPIs are created, and in the end, they go to the end user tools where they are visualized in a way that has now been validated by the various stakeholders that we showed this to, but this is quite flexible. It's a quite flexible tool on how you show them what's the breakdowns. Once you have the data, you can show it in different ways. So when selecting the data sets, of course, OpenAIRE is part of the consortium and everyone is a big fan, but we had to make sure that the data sets we picked aligned with the methodologies of the project. So it is extremely important for evidence-based STI policy making to use data sets and combine and link data sets so that you have a system that is comprehensive and timely. So it encompasses various aspects of the society and in a smart way so that you can connect what is going on in science with what's going on in another sector. Now, this can be done via topic. So, for example, I want to invest in green hydrogen. Present to me a picture of Greece for green hydrogen. What's happening in sciences? What are the collaborators? What's happening in the industry? Are there any patents? Are there any actual companies on that? Do people know about it? Several types of questions. So in order to facilitate the connections across these different sectors, it is extremely important that almost every data set that we use to be able to break it down, to be granular enough so we can have topics, organizations, specific research outputs, which means innovations basically. So you really need this granularity. And at the same time, you need the data sets to be open and fair, as much as possible, of course, without sacrificing content. And the importance here is that since policymaking should be ideally transparent, replicable, and trustworthy, the only way to do this is to use open data and open and transparent methodologies. And this is why we went to the OpenAIRE graph as the main source of data, as the starting point. I'm going to skip this because you saw it. So it's right here in the middle of the circle. The first, the S in STI and the R in RNI is what's happening in the scholarly world, in science, let's say. So we start with the OpenAIRE graph, and then from the information that we extract from there, or the metadata that is already available in the OpenAIRE graph, we link it to different sectors of the society and different types of data. For example, we have linked it to PatStat, to the patents, using the organizations, the citations, and so on. We have linked, then we link science to industry by looking at the type of things that companies are working on and how they're producing research on these topics, given the company names, for example. Then we want to have a picture of what's happening with ESG reports and compliance. So we split the industry in specific topics, and we check their performance there. Again, the original split comes from the what innovations companies are working on, right? Which we get from the OpenAIRE graph and track later on. Then we have the regulations. An interesting example here is we found, for example, that the topics in agriculture research in the OpenAIRE graph are quite technical. If you look at level 3 or 4 of the fields of science classification that's integrated in the graph. However, regulations in agri-foods in the EU, almost all of them have to do with labeling and designation of food products and so on. So here, for example, one sees a disparity between what's happening in the regulatory work and what's happening in research. Then we have policy documents such as clinical guidelines and other domain-specific sources that we use, clinical trials, drugs, and so on. Again, there are various ways to make these connections. And also because sometimes information is not openly revealed. So for example, let's say you have a collaborative group of researchers, they work together on something, they produce a publication, but when they go to patent it or make a product out of it, they don't necessarily refer to the publication or to a switch name. It's a different, let's say, like drag, or there's a bit of an alteration there, but you can use the subtopics, the organizations, and so on, the types of innovations to actually track them as they go through the society. So the richer the information in the OpenAIRE graph, the better the connections you can make, the better tracking you can have of the societal impact of research and of the STI status of different sectors of the society, and the more informed the policy making can be. I said so many things. Okay, so the particular use cases that we have in the STI viewer are for agenda setting, so for energy, agri-food, and artificial intelligence for the EU and Greece and Spain, and for evaluation of programs, we have done it for cancer. So this means that you go from various data sets and so on to actual policy insights. So I'm going to leave some time for questions, but if anyone would like to have access to the STI viewer, we kind of do access on demand right now. Please shoot me an email and I'll be happy to give you access so you can play around. So basically, to conclude, unlocking new potentials in STI requires an open, comprehensive, timely, and trustworthy source to link research to society and industry and all the advancements that are happening. So we use the OpenAIRE graph within IntelComp to lead to be like the stepping stone of the STI analysis. And we combine it with additional AI-driven analytics, because OpenAIRE graph also uses AI for different parts of it, in order to achieve this policy intelligence, so that we can help policymakers make more informed decisions and basically be able to manage the amount of information that's out there in a straightforward way. That's it for now from me. Thank you.
Thank you, Anna. I don't see any questions in the question and answer chat, but please feel free to raise your hand and ask questions to our speakers. Meanwhile, I would like to ask to you, Anna. You present a lot of challenges that you faced during the project. For instance, how to discriminate some data. Do you want to mention maybe the biggest challenge that you had and your biggest achievement during this project?
The biggest achievement we'll see, but so the biggest challenge is that all these different data sources use different language. So I think that is huge for a big problem for the AI tools. So something that works well on scientific documents will definitely not work well for legal documents, as an example. This is one challenge. The other challenge is that the industry is we used company websites in order to collect all the information they have up there, and that is data that is not really cleaned. So some information is provided, but one company could have like 200 web pages, some expired, some still in use, with lots of text. So of course that's difficult. And actually what worked well is tracking the innovative activities of these companies through their use of research, clinical trials, patents, whatever, and then going and confirming that we can find these on the website. So that was a nice way to have the validation.
Thank you, Joanna. Yeah,
Thank you.
I guess there are several registries for clinical trials. For instance, I am a researcher in life science, so I used a lot clinicaltrial.gov and this kind of registries
That's what we used for
for that. Okay.
for the project.
And sometimes many partners are asking also what are the data sources for patenting. And if there is a way to link the patents and maybe the clinical trial.
Yes, well, so we use the EPO, the European Patent Office PatStat dataset for that. And but clinical trials are, well, you can always link them through citations. But for example, clinicaltrials.gov, when they cite publications, but they don't mention the one. There's always one publication that's the one linked to the clinical trial, but they put them all together. PubMed has a nice field to add, but unfortunately not many people use it. So metadata completeness would help so much. But patents are the PatStat dataset has a lot of information to be used.
I don't know if Thanasis is here and he can turn on the camera. Because we spoke a lot also about data sources. Maybe one of the questions that a lot of users usually ask to OpenAIRE is about the duplication, the cleaning process. I don't know if you want to say anything in depth since we have some time.
Yes, as you all understand, to build the OpenAIRE graph, we collect information from a lot of sources, and in many cases there is an overlap. And this means that sometimes you have slightly different metadata for the same entry. So you need to decide what to keep. Other times it is not evident which are the entries, which are the records in the original sources that refer to the same entity. So, for example, they are not provided PIDs for all the records. So for these reasons, it was required for OpenAIRE to do this work, to implement various deduplication workflows. The most important one is the one that is trying to identify duplicates or different versions of the same research product and group these instances together so that you can have everything in one record. The respective algorithm is based on different approaches. For example, it uses some of the metadata like the title and the authors of the research product. But again, all the details can be found inside the documentation website that I mentioned earlier, and I think that someone also pasted here in the chat. So if you would like to know more, you can find all the details there.
Thank you, Thanasis. Another question to you, Anna. Since you use a lot of the statistic also for extract data to be used by policymakers and national environment. Do you use other external data sources beyond the one that are inside the OpenAIRE graph?
Yes, many, like in the picture. So we use PadStat company websites, the ESG reports from the websites, clinicaltrials.gov, DrugBank, and so on and so forth. Eurolex, SEDAFOP, Euraccess, many datasets.
So if any policymaker is here and they would like to use or they would like us to replicate somehow the project that was mentioned today as the IntelComp, feel free to reach us and to reach Joanna, as we have already some know-how now to help you and to provide the data or also to guide you through these challenges, right?
Absolutely.
Is there anything that Joanna maybe you couldn't mention in your presentation and you would like to add?
No, nothing that comes up off the top of my head. We have a long way to go into kind of maturing all these systems enough so that they can be used. And I think since they're new, we should all spend a lot of time on the documentation, which everyone hates. But I think having a transparent methodology will go a long way, because usually when we present this stuff, people are very interested and they want to use it for insights, but not directly for policy making, maybe. So it would be nice to know from the policymaker side what is needed to make it, to move on to the next step.
Did you add, did you have any particular use case, maybe Spain, if I remember well?
There were 3 use cases for, do you mean from policymakers?
Yes.
I mean, Facit is a huge part of the project coordinator, and they participated also, and we had the AI Living Lab was in Spain. And we presented it to policymakers in the EC last week. It wasn't a goal of the project to integrate it in their systems, but there are several units working on that type of stuff, let's say.
Thanks, Jonna.
Thank you.
So are there any other questions? So the first questions that we have was from Amanda in ROR, which is the Registry of Organization. And probably this is why Thanasis also mentioned the affiliation issue that is part of the metadata information that we get. OpenAIRE has a service that is for the community, which is called OpenOrgs, and it's helping the community to curate and duplicate the affiliation or make a parent-child relationship. I don't know if Thanasis or Joanna would like to comment on this part of the graph. Maybe Thanasis.
Yes, just as I mentioned earlier as well, the information about the connection between the organizations and the research project is very useful, and not only in OpenAIRE, but also in other relevant initiatives. There is a lot of effort in trying to make this type of connections available for everyone. And as I mentioned, we are trying to improve our coverage regarding this. OpenAIRE has a large, I think, has a large the benefit of having very close the respective community. As you mentioned, there is this tool, the OpenAIRE, that people from different organizations can curate information about how different um, departments are related, how different names of organizations are connected to various pits for organizations like the ROR ones. I know that also ROR is working. Of course, we get information from ROR as well, and I know that ROR is also working together with Crossref, for example, because currently the information that Crossref is providing regarding this is not that complete. If I'm not mistaken, about 20 to 25% of the Crossref records come with affiliation information, at least in the dumps that they are offering. And this in the form of, in most cases, of affiliation strings and not identifiers. In any case, there is a lot of work on that, and some things that we are considering in OpenAIRE is to take advantage, as I said, of the communities that we have. For example, for Monitor, we have various representatives of organizations that are collecting this type of information, the connection of their own organization to particular research products, because, for example, each organization is trying to collect this type of information to include it in their website or in their annual reports. So we plan to exploit more the fact that we are close to these people, that we are offering them some useful services regarding Monitor, and in the context of offering them a better experience, we can also give them some tools to curate this type of connections as well. And we think that this will be very useful towards improving the coverage that we are providing, unless for those, at least for those organizations that are interested to get services from OpenAIRE.
Thank you, Thanasis. I will go back to Joanna and her presentation. During your presentation, you said that for the agricultural and veterinary data, you found much more technical data than maybe publication or
No,
something.
let me say it again.
Yes.
So the topics in agriculture that research is going on are quite technical. However, the regulations in agriculture that we see are mostly on the labeling and designation of different types of food products. So, I mean, I cannot say for sure an expert would be able to understand this better, but it would seem like the policy terrain is a bit behind the technological advancements. Whereas in the energy domain, we see that both the topics in research and the topics in regulations are quite technical.
Thanks, Joanna. Here in the chat, Amanda comment on the question before or the discussion from Thanasis. So, Amanda, would you mind if we give you the opportunity to talk with the microphone?
Hello all.
Hello.
Yes, no, this was a very, very interesting presentation. I mean, I know we've looked before at what OpenORGS is doing, and of course with OpenAIRE. So yeah, and I saw your recent announcement that you've been using, you've begun doing a lot of affiliation matching of strings to ROR. So we're really happy to hear that, and it's great to hear that it's the OpenAIRE, how the OpenAIRE graph is being used. So yeah, looking forward to even more case studies.
Yes, thank you, Amanda. And please join us in the community calls that was introduced from Thanasis. So next year, starting from the 17th of January, we will have these community calls in which you from users or partners or collaborators, internal, external data sources will be able to speak and to explain to the community what are the challenges and the issue on improving this research knowledge graph. So these big aggregators of persistence identifiers that was explained by Thanasis. So you are invited, Amanda, to join us.
Yes,
And
I am already registered for the next community call. So yes, we'll see.
amazing, amazing. I don't know if there are any more questions. Otherwise, we can conclude. Maybe Thanasis and Joanna, she would like to have a final statement.
Yes, let me start. So first of all, thank you all for the interest and for participating in this call. Again, I would like to say that it is very happy for us every time that we are investigating what it is possible for people that are consuming data from the graph, that are using the graph in practical use cases. And the IntelComp project that is now ending was one of these cases. We were very happy to support the respective activities. And I think that the results were very interesting. And with that being said, I give the mic to Joanna to have the last statement.
I better make it a good one. So, I mean, being from both OpenAIRE and someone using the graph or other stuff, it's quite interesting to see and understand a little bit better how it can be used and what ideally we would also have in any scientific database, and how the community should work together to work on metadata completeness and all that stuff. That would really help for the applications, besides what all the besides collecting the data and duplicating it and so on. Personally, this societal impact of research is an important, I think it's a very important aspect, and I'm excited to see future research on similar applications of the OpenAIRE graph. It will be very interesting. Thanks, everyone.
Thank you. And if you have any other case studies and you are using the OpenAIRE graph, please contact us to be invited in our community call and present your case studies. With this, we are concluding this webinar. I would like to thank you all of the speakers to be here and the participants to listen to us and to ask questions and to participate. So thank you and have a good day and Merry Christmas and Happy Holidays. Bye.
Thank you,
Happy
everyone.
holidays.
Goodbye.